Hey guys, I'm Sayed from Intellipaat and I welcome you all to this session on Hadoop. So guys, 2-3 decades back, the data which we had were very small, and to find meaningful insight from that small data was quite easy, right? But because of the advancement in technology, World Wide Web and the various social media platforms, the data has grown enormously. And to store, process and find meaningful insight from that huge data, it has become a quite challenging task for the traditional storage system to store it, process it and make a better decision. So that is why Hadoop came into the picture. So considering the kind of popularity it has, we have come up with an end-to-end session on Hadoop where we have covered all the major concepts of Hadoop. So if you watch this video till the end, I am very sure you will have a better understanding of what this technology is, what is Hadoop. Okay, but before I go ahead and start the session, do subscribe to Intellipaat channel, like and share this video so that we can create more such informative content for you, right? So let's have a quick glance at the agenda. So we will start off with a use case, so where we will see why Hadoop came into the picture. After that, we will talk about the two major parts of Hadoop, that is HDFS and MapReduce. After that, we will see how we can transfer data from Hadoop to other external data stores using Scoop. Later, we will see how we can process data using Hive. And after that, we will see how we can analyze and manipulate data using Pig. And finally, there is a mini project where we will work with MapReduce, Scoop and Hive. So I hope the agenda is clear to you guys. Let's start the video then.
So let's start with a very small story and we should be good to go. So I am Jeff Bezos, CEO of this e-commerce site called as Amazon. And you guys are my technical guys. So as of today, our organization looks something like this. We have our e-commerce site and that runs out of Oracle. We have our inventory and that runs out of MySQL. So life is very easy over here. Everything is awesome. So now if I wanted to answer a question, let's say how many iPhones should be ordered next month? Very simple stuff, right? Now to do that, typical way of doing things would be to load all of this data to a data warehouse. Let's say Teradata. And then you basically do your reporting. So that's where you have tools like Tableau and ClickView. So all of your data gets generated, you load it into a warehouse and life is very simple. But there's just one problem. So the real problem in this whole setup is that this would have worked very well till let's say 2000 or 2005. Today, we are in 2018 now and the questions are not that simple because the amount of data that we're looking at is very, very huge. So let's take a simple example. Now, if I was to change the question and say how many customers bought the iPhone, loved it, but hated the delivery. But instead of talking to us, they vented anger on Twitter. Now, first thing is that the data which is coming from sources like Twitter and other sources like your sensors, network logs and cloud. So this data being generated is really, really huge. And it's not going to fit into your traditional database systems, okay? So Michael has a question here. He asks, are you talking about big data? Yes, Michael, you are absolutely right. So all of this huge amount of data coming from different sources and present in different formats is nothing but your big data. And we require something new to store and process this big data. So that's where we decide to bring in another system. And the system is called as Hadoop. So now think of Hadoop in a very crude way as a very big data warehouse. So it can take data from anywhere and it can easily host a single master and theoretically tens of thousands of nodes. It also gives you two services, storage and process. So this guy can get data from traditional databases and other sources as well. Now this guy lets you store data and process the data. So think of Hadoop as somebody who complements your warehouse, typically to store a lot of data and then process it. Now, after you store and process the data, whatever final processing is done, you can load that final thing into a warehouse. And that is what is called as analytics. And you're free to directly connect to a reporting tool also. That is also possible, guys. So based on your pattern, you can choose what you really want to do. So that's the idea behind Hadoop. So you put all of your data at one place and process it. And whatever comes out, you can load into a warehouse or you can directly connect it to a reporting tool. And there's another instance. Now, if you load this back to Oracle, man, it becomes recommendation engine. So think of it this way. From all the sources that we've got our data, we learned that 85% of people buying iPhone also bought a screen guard. And 81% people buying an iPhone also bought a back cover. Now, once we learn this within Hadoop, we can load this back to Oracle. And when the next customer comes to our e-commerce site, we can always show them that people who bought an iPhone also bought screen guard and back cover. So think of Hadoop as a very big data store. It can store the data, process the data, and then you can use it the way you like. So guys, I hope everyone is clear on what Hadoop is. So just give me a quick confirmation so that I can move ahead. Okay, so Ram confirms that he's clear. So does Anne. Okay, so seems like everyone's good. So guys, now we'll understand the storage and processing part of Hadoop. But instead of just going through the names of the processes, I want to take a small story, because that way we'll have the entire understanding. So this is Kailash, CEO of Tama Consultancy Services. And the company's presence is in over 150 countries. And people all over the world love the company. So just yesterday, the company's Facebook page got 1 billion likes. So now the CEO wants to create a huge dashboard where they get to see the whole globe, and on hover of each country, it displays how many likes they got from that country. So now this task is assigned to Ajay, who is the project manager, and he's supposed to get the dashboard made in 4 days. Now, let's say Ajay wants to use Hadoop for this, and he has 2 members in his team, Mr. Admin and Mr. Developer. Now, Ajay tells Mr. Admin, dude, go set up the Hadoop cluster. And he tells Mr. Developer, listen, you're supposed to develop the whole dashboard. So let's see what happens right now. So first admin comes in, he purchases 5 machines and decides that 1 will be master and 4 will be sleeves. So Mr. Administrator has come to work and he's setting up a 5 node cluster with 1 master and 4 node sleeves. And Hadoop is all about storage and processing. So on the master, he installs somebody called as storage master. And on the master again, he installs processing master. Now on the slaves, he installs storage slave and processing slave. So he does this for all of the slaves. Now admin tells Ajay, boss, setup is done. Go ahead and ingest data and write the program. So now Ajay calls Mr. Developer and says, Mr. Developer, go ahead and please load the data and write the code. So the developer takes the data, which is, let's say, facebook.json, and the file size is around 640 MB. So when he writes to storage master, the file is actually broken down into blocks of 128 MB. So 640 divided by 128 means 5 blocks, and each block is replicated 3 times. So that makes it 15 blocks. Okay, so there's a question from Deepak. He asks, why is the block replicated 3 times? Good question, Deepak. So we actually have the concept of fault tolerance in Hadoop. Now, even if the original block gets corrupted, you have 2 more copies of that block to retrieve the data. And this is what makes Hadoop so reliable. So does that answer your question, Deepak? Alright, so Deepak's good. So now these 15 blocks of the original file are distributed across different slave nodes. So let's say 4 of these blocks are stored on the first slave, 4 on the second sleeve, 4 on the third sleeve, 2 and 3 on the final one. So now the data is ready. It is already broken down into blocks. But when it comes to storage master, it will only have the metadata. So the metadata looks something like this. Now facebook.json is nothing but block 1, 2, 3, 4 and 5. And block 1 is present on slave 1, 2 and 3. Block 2 is present on slave 2, 3 and 4 and so on. And this is what is stored in the metadata. So there is no problem of memory in storage master because master is storing only the metadata and not the entire data. Now because of that, memory is not at all an issue. So irrespective of how big a file you write, it uses memory of name node only for metadata. But the original data is actually written to the sleeves. Now let me just give you guys a simple example for this. So let's just say there's a project manager who has 4 people in his team. Now project manager just knows what tasks people are doing, but all the tasks are actually done by the slaves. So that's why manager is not the bottleneck over here, and neither is his capacity to know which data is stored where and which task is running where. So manager is doing nothing in this. He only has the metadata. Okay, so now your data is stored, developer has taken the data and he has written it to the storage layer, and all the data is spread across and it's done. So now the developer goes ahead and also writes the program. And because the task is to find the number of likes by country, let's say the program name is group by Java program. Now this Java program gets submitted. So the processing master copies this code on every machine. Now master will basically say that, okay, listen up Mr. Four Slaves. Slave 1, you process block 1 and block 2 which is local to you. Slave 2, you process block 3 which is local to you. Slave 3, you process block 4 which is local to you. And slave 4, you process block 5 which is local to you. So do your business locally, don't talk to the network, and the job has to be done. And then you get your final output, which can then be directly shown on any reporting tool, or you can load it to a warehouse and perform analytics on top of it. So this is how Hadoop really works, guys. So this is Hadoop for you. So now let's quickly get into the process names. So far we've learned that Hadoop gives you two services, storage and processing. So the team that gives you storage is called as HDFS, and the team which lets you do processing is MapReduce. Now again, since this is master slave, so the master in HDFS is called as name node, and the slave is called as data node. In MapReduce, the master is called as job tracker and the slave is called as task tracker. So for storage, it is name node and master node, and when it comes to processing, it is job tracker and task tracker. Simple stuff, isn't it? So life is very, very easy over here. Now, this particular setup had one very serious limitation. You could only write programs in MapReduce. So whether you like it or don't like it, you could write programs only in MapReduce or any other framework that runs on MapReduce, but you can't have anything else. So let's take a simple example. Let's say I'm a layman, like a proper layman, guys. Now there is a problem in my iPhone battery. So can I just buy a new battery and put it in my iPhone? So can a normal person walk into a store and buy a battery for the iPhone? Obviously not, right? And this is because Apple tells you that if you want to use my phone, you'll have to use only my battery. You like it or you don't like it. You can't just buy any battery and plug it into the phone. Very similarly, if you wanted to use Hadoop, Hadoop would say, hey buddy, use it. But you have to express yourself in MapReduce only. So it's a very serious limitation. And that is why it was called as Hadoop 1.x. But what you really wanted was something better. So that's why we had another version of Hadoop where we had storage, but instead of MapReduce, there was a new component called as Yarn, which is nothing but resource manager and node manager. Now what Yarn would do is it says, I'll give resources to anybody, be it MapReduce, Splunk or Storm, it doesn't really matter. So in Hadoop 1.x, MapReduce was the only way. In Hadoop 2.x, MapReduce is one of the ways. I am reiterating it, guys, so just please concentrate on this. So in Hadoop 1.x, MapReduce is the only way. In Hadoop 2.x, MapReduce is one of the ways. So now this course is all about 2.x and we're not going to discuss 1.x at all. And the reason that I explain 1.x is because, let's say, can I explain good health without explaining bad health? Probably is going to be tough. So very similarly, if I had to explain 2.x, I should first show you 1.x and the serious limitations over there, and that's when I bring in 2.x. So 2.x is basically a generic resource manager which says, everybody who needs resources, come, I'll give you the resources so that you can do the job. So that is how 2.x really works. So now let's look at the processing part in Hadoop 2.x. Now here we'll have Yarn master, which is called resource manager. We also have the Yarn slave. So my storage layer remains pretty much the same. I write my data and it is processed. But when I submit my job to Yarn master, Yarn says, hey man, I don't know how to run MapReduce, but I know a guy who is called as app master. He can do MapReduce for me. So I'm the resource manager. I only give resources to people. I don't know how to do processing, but I know another guy called as app master and he'll do that job. So now Jan will initialize an app master on any one slave. Now this app master is basically a process that'll do the job. So who's responsible for the job? It's app master, guys. So Jan master says, hey app master, I have a new job for you. Why don't you do it? So now app master will go to Jan master and say, boss, if you want me to do the job for you, please give me the following things. So give me 2 resources on slave 1, 1 resource on slave 2, 1 resource on slave 3, and 1 resource on slave 4. Why? Because data locality is important. So Jan master says, okay, go ahead, take the resources. And the app master can go ahead and fire the job everywhere. So the idea here is Jan master does not do the job. It only gives the resources. So this is Jan for you. There is one more thing as far as this whole detailing is concerned. In 1.x, MapReduce is the only way. In 2.x, MapReduce is one of the way. So why do we need to go for 2.x? Because you need more options in life. As simple as that, guys. So I'll give you a very simple example. So there's this company called Foodpanda. So Foodpanda is a company that does food delivery for you. Now if you call Pizza Hut, you can only get pizzas. But if you call Foodpanda, then you can order from any restaurant that you really like. So think of Jan as Foodpanda, which says, listen, I don't make food, but I can always provide food services to people so that they can order whatever they want. So with this explanation, our entire landscape of Hadoop from the architectural working perspective is done.
How does MapReduce really work? Okay guys, so it's a very simple concept. Yeah, books, a lot of people around, when you read a lot of blogs, would try to complicate it. Well, it's important to complicate because that's how people make money, right? So it's very simple. So just focus on the example, focus on the story, and we are done. Just focus on the story and MapReduce will be done. It is one of the simplest things that you would have heard or you would be learning today. People would make big things about MapReduce, but it is that simple. So just focus on the example, my friends, and we are done. Just focus on the example. Focus. Tighten your seatbelts and focus. MapReduce is processing, but if I was a student, I would ask one thing to myself. What nonsense. Blocks are broken. Data is individually getting processed, but somewhere it has to consolidate, right? How will that work? Who will do that? That is where you have to understand the concept of MapReduce. That somewhere data is broken, but boss, somebody has to consolidate. How will that work? And that's what we are going to see right now. So it's going to be very simple. Just pay attention, it will be done. Okay. All I need is your attention for next 25-30 minutes and we are done with this topic. So let's say we have 4 guys. We have 4 guys. Ajay, Abhay, Amit, Abu. So these are 4 friends who work for an organization. Ajay, Abhay, Amit and Abul, 4 guys are there who work for this organization, and their manager has told them that for next 1 year they are supposed to work on every Saturday and submit a report. Oh man, this is bad for them, right? So 4 guys, Ajay, Abhay, Amit and Abul, 4 guys. These 4 guys are supposed to be in office for the next 1 year. Every Saturday they are supposed to come and they are supposed to do some job, whatever, some report they have to generate, some XYZ report we don't care about, but they have to come to office. Now Saturday is a weekend and you don't want everybody to waste the weekend. So these 4 friends, Ajay, Abhay, Amit and Abul, what they do is they say that let's have a small deal that let's come at 8 o'clock in the morning. Let's work till 10 o'clock. Let's work from 8 o'clock to 10 o'clock. And 10 o'clock, one guy will stay back and consolidate the whole thing. One guy will stay back and consolidate the whole thing. So that not everybody is wasting the whole weekend, right? I mean, we'll come for 2 hours and then every week we will take turns. Like week 1, Ajay may stay back, week 2, Abhay will stay back, week 3, Amit will stay back, week 4, Abul will stay back. So that's fine. Let's do that. So it is this Saturday, Early morning 8 o'clock, Ajay, Abhay, Amit and Abul, all four are in office, and from 8 o'clock they start working. 8, 9, 10, everybody is done with their work. 8, 9, 10, 10 o'clock everybody is done with his work, and this week Amit is supposed to stay back. This week Amit is supposed to stay back. Okay. So all of them will hand over work to Amit. Amit will consolidate and give the output. My friends, this is MapReduce. Nothing big. MapReduce is so very near real to what our life looks like, how consolidation looks like. 8 o'clock to 10 o'clock, when people are minding their own business, that phase is called as map phase. Whenever you hear map, that means mind your business. That means you are not looking at the left how many people are there, you're not looking at right how many people are there. You are just doing your job. That is map. At 10 o'clock, everybody is done with the work. And when you push everything to Amit, that is called shuffle. And Amit will consolidate everything. Don't worry how that works. That is sort. And finally, Amit will do the whole thing. We will see what is sort, and that is called reduce. So my friends, all I want you to remember one thing about MapReduce is MapReduce people will make it very, very tough, but it is divide and conquer. All you should know is map means divide, reduce means conquer. Map, divide, reduce, conquer. Map, divide, reduce, conquer. Okay. All right. So let's take one more example and we will really simplify it. Okay. Let's take one example. So I want a number of students from each country. Okay. Now let's say all student details are in a file of 189 MB. That's fine. I don't know the size. You also don't know the size. Let's have it 189. So I'm putting 189. You're free to choose your number. That's fine. One thing is sure that with 189 MB, there'll be two HDFS blocks. How many blocks? Two HDFS blocks. 128 MB and 61 MB. Now in map phase, we will have two mappers. How many mappers? Two mappers. Now the way map works is, it will take one student at a time and basically process it. I'm supposed to find students by country. So the mapper output will look like some students will be here, some students will be here. Because mapper will take one record at a time and process it and give the output. So our mind your business phase is over, where two blocks were minding their business without knowing what is happening on the other machine. They were only interested in what is happening on their machine. They were looking at one record at a time. That's how mapper is coded. Okay, life is good. After this is done, there is a reduce machine and everything should go here. So the act of throwing data here, oh, this is called shuffle. But my friends, before reduce can start, we need to create something called as groups or bags. And here there will be 5 groups created. Let's see how the groups will look like. China, C, D, okay, so it will be India, Malaysia, RST. Sorry, I'm not good at ABCD. This phase of creating bags is called as sort. And finally, reducer will take one bag at a time and say China 30, India 30, Malaysia 20, Singapore 10, Thailand 10. This is map reduce for you. Simple stuff. Divide and conquer. Divide and conquer. Divide and conquer. Simple stuff. Now, it's possible that it may still appear to be, no man, it's pretty complicated. Well, you have been doing map reduce since the very beginning of your career. Let's look at this. Now, the previous example that I saw, can I say this was nothing but select country, comma, count of star from students table, group by country. If you really see there were 3 students or there were 100 students, how will it go through? The RDBMS will find a way to go through each and every record. Okay, so eventually there is loop where scans each and every record. Then if the bag is created, if the group is created, insert in the group, else create the group. Don't worry, it's simple. And finally, for each group, perform count. Is not created. Think of it this way now. Even RDBMS will go through each and every record. Now, let's say first it finds India. First it finds India. Is India group created? No. Sorry. If the group is created, insert, create the group and insert it. Okay. So scan each and every record. If the group is created, insert in the group, else create the group and insert it. So let's see how it looks like now. First it looks at India. Is India group created? No. So create a group and insert within India. Okay. So like this it will insert, finally have India, China and all. So the bags will eventually look like, here each and every record is scanned, and here the bags will look like, the groups will look like China, India, and finally here for each bag you will say China 30, India 30, blah blah blah. Now let's phase it out. Going through each and every record, it's called map phase. Going through each and every record, it's called map phase. Putting everything in group, creating bags, it's shuffle and sort. And finally, performing the count or performing the aggregation. Reducer. This is MapReduce for you. It is that simple. It is that simple. So if you're clear with this, we are done with MapReduce. There are two more small details which I will add, and we will be looking at the code, but that's MapReduce for you. So just two more small things here, and we will. So MapReduce, everything is clear. Only problem is, man, that this diagram somehow has serious limitation that all the data should go to the same reducer. What if that reducer does not have enough storage? Then we are in deep trouble. Then we are in a serious trouble. See, this diagram is excellent diagram, but with a limitation that all the data should go to the same reducer. Man, if in big data, if you're talking of a diagram like this, there are thousands of machines running, everything going to one reducer, everything will be dead, right? So the point is, by default, the number of reducers in MapReduce program is 1, and you can change it, but you can change it. So if I wanted to have a load balancing, I could go for should go for 2 reducers. But then if there are 2 reducers, my whole thing goes in a mess. Why it's a mess? How will I know what should go where? How will I know what should go where? And that is where a component just below the mapper is running, and that's called partitioner. Partitioner will decide which data should go where. So partitioner will ensure some data goes here and some data goes here. How it will decide, we'll see. So relax out. So partitioner may decide that, okay, China and India will go to reducer 1 and remaining 3 will go to reducer 2. Okay. And then here we will get China 30, India 30. And here I'll get Malaysia 20. Sorry. This auto suggest can really ruin your relationships. Singapore is 10, so it's 3080, yeah, and Thailand is 10. And then the developer can easily just run a merge command, which will just merge these 2 files, but the files are complete right now. So that is possible because of partitioner. Partitioner is the guy who load balances, but on what formula? Let's understand that. Partitioner uses a generic formula which says key dot hash code. Now hash code is, just don't worry, it's some integer. It is generated by JVM, Java Virtual Machine. So key dot hash code divide by, or modulo, not divide by, modulo number of reducers. Key dot hash code modulo number of reducers. So think of it this way. Let's say India dot hash code. Let's say it's not in my hand, it's not in your hand, so let's put any number. Let's say 80. China dot hash code 86. Malaysia dot hash code 71. Singapore dot hash code again 71. Who knows? Nobody knows, right? So neither am I in a position to tell what it is, and neither are you in a position. Thailand 79. So if you see, modulo 2 is 0, modulo 2 is 0, modulo 2, because the number of reducers are 2. Modulo 2 is 1, modulo 2 is 1. That's how it gets decided who will go where. That's what is done by hash code partitioner. So partitioner by default works this way, and it is a guy who will basically load balance the whole thing. It will simply load balance the whole thing. It is as simple as that. Now, neither do you know hash code, neither do I know hash code. If everybody was having an even number, then everything would have gone to one reducer. That would have been a problem. Okay, so that's where a developer can come in and he can change this logic. He can write Java code to change this logic and say that, oh, I don't like this partitioner, I would like to have a different partitioner. So a developer can do that also. A developer can do that also. All right. So this is partitioner. Now there is one more last topic, combiner. Okay, let's do one more topic quickly, small topic. Load that. So partitioner is basically a load balancer. Let's do one small thing. Now, what comes out of mapper? So what comes out of mapper is India 1, China 1, Malaysia 1 and all that, and we are consolidating China and India. Why can't we do something like this? That we add everything up and we directly send India 22, China 22, Malaysia 6, Singapore 6, Thailand 6, let's say. And here itself we consolidate India to be 8, China 8, we know India, Malaysia 14, Singapore 6, and Thailand 4, Singapore 4. Now, instead of China and India like this, with combiner, we will get China 22,8, India 22,8, and here we'll get Malaysia to be 6,4, sorry, 6,14, 6,4, 6,4, and we get the consolidation. This is done by one guy sitting before the partitioner called as combiner. So that is combiner and partitioner. So that is combiner and partitioner. So now this kind of consolidates the entire map reduce for us. We understand map, that is one record at a time. Then we understand partitioner, which is load balancer. But before load balancing, if we want to combine something, we can run a combiner, and then we do the reduce part. Okay. So let's understand, guys, carefully. As a programmer, how do I predict my number of reducers? Now, actually, there are no royal ways, but there will be a couple of tips out here. So let's understand. Okay. And in 30 seconds, I'll put the answer and check if your answer is confirming. Answer should be 12 reducers. Why you should go for 12 reducers? Because here your use case is very clearly telling you that, listen, for Bank of America 2016, I want monthly revenue where I would like to have 12 output files, each file having 1 month's data. That means your use case is very, very clearly telling you how many reducers are required. In a year, you cannot have 13 months at all. That's not possible. So for most use cases, this is what will be the pattern. Now some cases when we don't know, like say word count, there is no classification. Well, then it's trial and error. Okay. So, and here knowledge of data will also be required. There is absolutely no magic on this one. It's trial, error, and okay, so that's the answer. Unfortunately, if your use case does not tell you what is required, then you are in trouble. Not trouble, but yeah, you will have to do trial and error, and there is no royal way for it, because that will also need a lot of understanding of your data. Okay. Okay, what kind of data it is, probably what kind of bifurcation we are looking at. You will have to do multiple runs to really settle down on a number that looks good for you, and there is no other way, because if your nature of the data changes, you are back to square one, but that's how it is going to be. So for example, in one of the places, right, what we really do is, let's say we do number of reducers to be 72. Now we just add, okay, this is the amount of RAM we have, and did some calculations that this is the RAM we have. Probably each reducer will take 1 GB RAM. Based on that, we choose, okay, let's have 144 GB RAM is there. Let's have 72 reducers for all the jobs where we don't know what it is. But that's always going to be changing. So there is no one royal way where I can say, no, this is how it has to be. But when your use case is perfect, like it clearly tells you, your manager comes and says, listen, I want monthly revenue of BOA for 2016, and even if he tells you that, you kind of know that, okay man, I can bifurcate by month and maybe have 12 reducers. That's the idea. Okay. Okay guys, so now here we come to map reduce, and let's understand this. So this is, okay guys, so this is like the final diagram of the day. So let's take up this diagram, and this will complete our map reduce explanation. Okay guys, so first I submit my job data, which is 640 MB. That means there are 5 blocks. When I submit my job, automatically my number of mappers, because the blocks are 5, will typically be 5, and I can specify number of reducers. And let's say the number of reducers is, let's say it is 2. It is 2. So I submit my job. Number of mappers will be 5 because the blocks are 5, and number of reducer as a developer I said I want 2. When I submit this job, AppMaster starts the job, and AppMaster tells so number of mappers is 5 and number of reducers is 2. When I submit my job, the AppMaster tells the yarn master that, listen, I will first start with the map phase, so please give me pi resources, 5 resources. And now I am replacing this word resources with containers. It's called containers. So AppMaster says, hello, I will first do mapper phase, give me 5 containers. Resource manager says, go take them, man, take 5, go enjoy. Now after the map phase is completing, the AppMaster will go and say, hello, I need 2 containers for reducers, and you can give me on any machine, because anyways there'll be some traffic. So resource manager says, of course, take your container for reducer. So let's say one reducer will run here, other will run here. And after map is done, all the data is coming from all the machines. This is shuffle phase. And now the reducer will run, and it will generate 2 output files. Output 1, output 2, which you can merge later. So now let's first understand how these labs are set up, how we will practice everything, and then we will basically go through the whole walkthrough. So let's jump onto it right now. Now before we jump into any of the labs, let's first understand the setup. Now I'm sure most of you will at base have a Windows laptop or a MacBook. Okay. Most of you will have. Okay, from your LMS, so Intellipaat's learning management system, you will download something called as a virtual machine. So now what happens is, there is this virtual machine which will run on top of your Windows operating system, and this is running an OS called as CentOS. Okay, so that's where CentOS is running. When you say Hadoop is already installed, following services are already running on your virtual machine. So even without, let's say, in case you've not gone deep into it, but these are 5 services which are already running on your machine. So the first service is running as name node, then you have data node, then you have secondary name node, then you have resource manager, then you have node manager, and then you have job history server. These are the 6 services that are running on your virtual machine. Okay. Now your setup is done. Windows, Mac, CentOS, Hadoop is installed. Life is good. Then you came for a theory. We did so much theory. Now it's time to practice 2 things. First thing is we should practice some HDFS commands. Okay. And second thing we will practice is MapReduce commands or MapReduce programs. So when you leave for the day today, you would be very clear that, oh, I have a virtual machine and Hadoop is properly installed. Yes, that was done. And today you practiced or basically you would see how to do it, HDFS and MapReduce. And then you can basically take your time to do that as an assignment. My Linux box, that CentOS Hadoop that you've got, it actually has 2 file systems. CentOS will have something called as Unix file system, and Hadoop will have a file system called as HDFS. So hope everybody is clear that Unix is different file system, HDFS is different file system. Today when we practice HDFS, we will be dealing with Hadoop file system. Okay. So this is the setup. This slide will be important to you. I'm sure everybody knows what is name node, but I'm just reiterating this so that this slide stays with you. Name node is master for storage. Data node is slave for storage. Secondary is backup of name node. So this we've covered in detail. Okay. Resource manager is master for yarn. Okay. Node manager, he is slave for yarn. But now there is a problem. Problem is, let's go to this diagram. That yarn, that is resource manager, has to maintain multiple frameworks like MapReduce, Spark, and so on and so forth. That's why resource manager says, I will maintain your job only till it is running. After the job is done, forget about it. Find a way to archive the status of the job. What I'm saying is, oh, you ran a job on Friday, today is Saturday. You want to see how much time that job took. Resource manager says, listen, it's not my job to archive that information. Okay, because I, as a resource manager, has to handle MapReduce, Spark, and so many other things. So for archiving the MapReduce job status, okay, there is this service called as, the name itself is very self-explanatory, job history server. Okay, think of it this way. It is status archival for MapReduce job. What I'm trying to say is, as soon as your MapReduce job is done, resource manager says, okay, bye-bye, I got your output, see you, and I'll forget the status. And that gets archived in job history server. So it's like an archival service. Think of it that way. Okay, dude, how do I believe a trainer that services are working or not? I should be able to see it in real world also, right? What services are running or not. Well, there is an interesting utility, and I will paste the command because it's an interesting thing. So there's a short command called as JPS, Java process status. It will tell you all the Java processes that are running in your cluster. Okay, so this is my cluster, and yes, trainer says Hadoop is installed, but how do I verify that? Let's do that with that particular command. It's an interesting command. So the command is sudo user java latest bin jps. So basically we are running a command called JPS. JPS full form is Java Process Status. This is our way of questioning. Listen, Mr. Cluster, can you tell me which Java processes are running? So our cluster is kind enough to say that OS name node is running, OS data node is running, OS secondary name node is running, OS resource manager is running, node manager is running, and the job history server is running. Okay, and I will paste this command in Evernote. Okay, so won't be able to paste, so I'll just type it. Sudo user java latest bin jps. And by the way, this command is not married to Hadoop. This command is married to Java. That means on your server, if any other Java process is running, I mean, take an example. Okay, let's give an example. Let's say on your laptop, in that cluster, let's say Lotus Notes is also installed. Lotus Notes is an IBM product which runs on Java. You will see Lotus process is also running. So this command is not married to Hadoop. This is married to Java. Okay, Java process status, JPS. Okay, so that's a command. With that, now let's move on to our thing. So first thing is, our first agenda is, hey dude, I want to practice HDFS. So the first thing trainer keeps on talking about HDFS is that Linux file system and HDFS file system are different. How do you prove that? Okay, let's run a small command. lsltr/, or let's simplify it more, lsltr tmp. So this is my temporary directory, and I see some files, keyring, jetty, virtual training, something, which is fine. Now I'm again running the same command. Okay, in front of you I'm just running the same command, but this time I'm saying Hadoop fs ls tmp. So here I was seeing tmp, here also I'm seeing tmp, but God, the content I see is different. When I see tmp for Hadoop, I see Hadoop yarn, but when I see tmp in Linux file system, I see so many other things. The reason is Linux file system is different, Hadoop file system is different. When you just run a Linux command, this is Linux command, and if you want to run a Hadoop command, you can always run it as Hadoop fs ls or hdfs dfs ls. Okay, so the idea is that this prefix will decide whether it's a Linux command or Hadoop command. This prefix will decide whether it's a Linux command and Hadoop command. So first thing is amazingly verified that yes boss, this thing is clear that they are two different file systems. How did I verify? On Linux I'm saying temp, I see something else, and when I say Hadoop fs ls temp, I am seeing something else. That means they are two different file systems. So that's good. So our hands-on has to be done on what do you call HDFS. Now the common pattern for Hadoop commands is Hadoop fs hyphen your Linux command. So most Linux commands will work like that. Hadoop fs hyphen and put the Linux command. Okay, so if Hadoop fs is not there, this is Linux command. If Hadoop fs is there, this is HDFS command. Okay, now there is one exception to this rule, and that is that we cannot do vi, that is we cannot edit a file in Hadoop. In Hadoop file system, once you write the data, the file cannot be updated. It's more like from a warehousing perspective, they never let you update. I mean, warehouses do let you update data, that's fine, but Hadoop file system will not let you update the data, So Hadoop is also called as worm, write once, read many. Hadoop is worm, write once, read many. That's simple as that. Okay. The second variation to this is In Linux, there is an amazing command called as cd. So I can say my pwd and I can say, let's say, cd workspace. And when I do my pwd, my present working directory changes. But my friends, in Hadoop, there is no cd command. That means, let's look at a simple example. I say Hadoop fs ls temp. Now I am tempted to say that Hadoop fs cd temp Hadoop yarn, and the cd command is not there. That means you are always supposed to give the full path and your present working directory is always, carefully look at it. If I say Hadoop fsls, it's showing my present working directory, and that is nothing but same as user training. Aggregation, output, input, same thing, aggregation, output, input. So what I'm trying to say about HDFS is very important. Let me note it down for you here. For most part, HDFS commands are very close to Linux commands. So there is no special practice required for you. When we run MapReduce program, you will end up practicing them. Okay. So if I just say Linux command, this runs on Unix file system. And if I say Hadoop fs Linux command, this will run on HDFS. So we are clear with this. Now, two important points for HDFS before we move to this thing. Two important points. You cannot update a file in HDFS. That is, HDFS is worm. Remember this word because this will save you a lot of trouble. Read many. Second, there is no cd command. You will always be at user, that is, in this case it's training, and for everything else please use the full path. So that brings us to the end of HDFS. Now you can just play with this. So let's quickly play with a couple of this. Hadoop fs mkdir. Okay, so I'm creating a new directory called as Apple. So what I see is Hadoop fs ls. I see a new directory called as Apple. Now Apple is a directory created in Hadoop file system. How do I put some data into it? Let's take a simple example. So in my Linux file system, I have a file called as, let's say, test.txt. So I'll say Hadoop fs put test.txt in Apple in HDFS. Wow, it goes. How do we see it? Hadoop fs ls, and we see a file text.txt. So two major commands to remember. One is put, okay, and other is get. Now if I want to get this test.txt dot outside, then I should use command called get. So get and put are two major commands. I can delete this file also. Hadoop fs rm-r apple / test.txt. Okay, so these are some of the commands. Now you will have lot of practice on it. See, by the time you complete this whole training, you will be a champion at these commands, because every hands-on that you do, you will have to use these commands. Okay, so that kind of brings us to the end of explanation of HDFS and how to play with it. We move to our next important topic, which is MapReduce. In our hands-on, we are going to look at a couple of things. So how to write a basic program and how to run it. how to basically, let's say, aggregate data, how to perform some kind of joins, and so on, so forth, so on, so forth. Now, before that, let's kind of understand the architecture of how you deploy them so that we are very, very clear with this. So pay attention. Yeah. So let's go ahead and do everything. Okay. So that the flow remains. So let's first talk of the same diagram here. Oh, I have Mac. Okay. I have CentOS. It has Unix file system. I have Hadoop file system. We already saw HDFS commands. Now it's time to run MapReduce. So let's first understand the deployment architecture. So on my CentOS, I will write this great code which is called MapReduce code. And oh, that code is written in Java. So I have code that. Good. When I submit this code, okay, it will get registered with the resource manager. So I'll be able to see on resource manager that. So leave the code part. Let's first understand the deployment. You write code on your CentOS machine. Write it. After you write it, when you submit, it goes to resource manager. Resource manager internally will call app master and say, okay, boss, do the job. App master will do the job. And after the job is done, the job will be archived at job history server. So don't worry about code. Don't worry about MapReduce program. First, let's worry about the deployment part so that we are clear with what is the flow. Writing code is easier part. Understanding the flow is pretty important. So without worrying about what I'm doing, let's submit one MapReduce program first. We will understand the deployment architecture. So we'll go step by step. Right now, you have to look at from a perspective that how will it get deployed on the cluster? Okay. So first, in HDFS, I have created a directory called word count input. I will first delete it in front of you. HDFS DFS ls or Hadoop FSLS, whatever you want to run. So there is a folder called input and there is a folder called output and apple and aggregation and aggregation out. I will delete everything in front of you so that we are very, very clear. HDFS DFS rm-r user training star. So please delete everything that is there. So it has deleted. So right now my user training directory is completely empty. And now look at it from a perspective of how it is deploying on the cluster. Don't worry about the code. We have whole day to look at the code and that's an easy part. Okay. So let's first create some sample data. So I'll say vi, okay, Intellipaat.txt. I'll say Intellipaat is one of the very first companies who got into big data. So I've actually created multiple lines, okay, who got into big data. So they have a big data COE. They are good at big data. They are very good at big data. Let's just say I'm putting something. The idea is that just mark your words that I have used big and data 4 times. So that means big is 4 times and data is 4 times. Okay, because we will run some kind of word count job. So this is my input data. You are free to put whatever you want. So this is in my Linux box. I want to put that into my Hadoop. So first what I'll do is HDFS DFS mkdir and I will create a folder which will be called as input. So I'm creating a folder called as input. Life is good. Then I say HDFS DFS. You can use HDFS DFS or Hadoop FS. Don't worry about it. It's the same command only. Okay. So call it biscuits or cookies. They are same only. Okay, so HDFS DFS put Intellipaat.txt in my input directory. So life is good. HDFS DFS ls input. So what I see is a file called as Intellipaat.txt. Okay. So now input is there. It's time to just run a code. So this is some ready-made code, word count.jar. I have written it for you. It's ready. Just leave it. It's fine. Right now we are not interested in how to write code. Hadoop jar word count.jar. The input folder I created is input, and the output that I will get is output. But right now my perspective is how does it get deployed on cluster. So we will see both of it. First, I will go to localhost and I will go to 8088. So this is my resource manager UI. Right now I have not submitted any job. This is simple. And this is my job history server. Okay, so let's just say, so this is my job history server. Okay, it's connecting. It's fine, it'll come up. Okay, so right now my job history server, this was my previous runs which are there. This is 0 applications. Resource manager has no applications. Now pay attention. I'm saying Hadoop jar word count.jar input output, and I say bang. Once I say bang, you see the job has got submitted and it has got accepted. We don't know the status because resource manager has just got it. Click on that and you see the job is still running. It is not complete. It is running. Let it run. It's doing something. We are seeing that. Let it run. But pay attention to the screen right now. Okay, there is a tracking URL which is application master. 24 seconds. Job is running. It is doing word count. That's easy. But look at it. The tracking URL changed to what? History. And it takes you to the job history server. It is taking you to the job history server. You can actually refresh it from here itself and you will see that the job will get registered here. So the job was submitted, it ran successfully, and it will appear in the history. Okay, so this is the job that I ran in front of you. Now this job, okay, this is where I will see the time and everything. So this job ran, it would run certain mappers, certain reducers. This job ran one mapper, one reducer. I can see the logs for mapper and I can see logs for reducer. Okay, so now just to understand the flow, we will first reiterate the diagram again. So this is my task. I can see my logs and everything in that. So the UI is there, click on logs and you will see logs. And that's how you understand the flow of how the job is getting submitted. We will come to the code. It's important to understand the flow. So my job has run successfully. I say HDFS DFS ls. I see output directory. Life is good. Within output, I see two files, success and part R00. You know why success is required? Success is a 0-byte file which is a flag. See, in enterprise you use tools like Control M, Autosys, or your own automation. If you're using an automated tool, how will automated tool come to know whether this job was successful or not? It looks for a file called as success. So this is like a flag whether this job was successful or not. And this part R00 is your output file. So there was one reducer, so it came up with one file. HDFS DFS cat. And I say paste. And carefully look at it. Data is 4 times and big is 4 times. So that's my output. So I have successfully run my job. Yes, we have not got into the code. We have time for that. Right now it's important to understand the logic of deployment. I wrote my MapReduce code. It was bundled as a jar file. So for guys who are not from Java background, just to give you information, jar file is nothing but think of it like an exe file for Java. Just think of it that way. this jar file was submitted to resource manager, and resource manager showed you on a URL which was port 8088, and resource manager tells you, hey boss, yes, job is submitted and I'm running it. It's running, it's fine. After the job is done, resource manager says my job is over, and the job history server has the status. That is how your flow will work. So you code, you deploy, and you see the status. You see the status. That's how it works. Okay. Now it's time. Now the next question that will be asked is, hey man, how do I write my code, and how do I bundle my code? So two questions now which are pending to be answered now is, how do I write my code? That's the next question we'll take up. And how do I bundle my code? Simple stuff. So these are two important questions to be answered. Once we answer these two, we will see some more programs on MapReduce. That will be the agenda. So now I'm going to talk about a problem as to how do I write my code and how do I bundle my code. Think of MapReduce program as three different Java classes. So I'll map this in the code, okay? So the first class, the main class, is called as driver. So that's your ignition point. Think of it like the place where in the car you insert the key. That's where you drive the whole engine. The second file is mapper, that talks about what should be done with each record. And then there is third file, which is reducer, which says what should be done with each group or bucket. So for example, the student's example, what should be done with each student, and here what should be done with China, comma, let's say 11111, the whole bucket. So the driver you initialize, driver will call the mapper will write its output, automatically framework will take care of shuffle and sort, then the driver will call the reducer and you will get your output. So as a developer, you are supposed to code three things. You will code the driver, you will code the mapper, and you will code the reducer. How shuffle sort works, that's something you will not code, because that's what framework will take care. It is as simple as that. Now if you have this diagram in mind, I will map this to the code. And it is that simple. Every MapReduce program, my friends, that you use will have these three classes: mapper, reducer, and driver. So don't worry about it. It is dead simple. You just have to relax out. There are three things to know. What should I put in driver? In driver, you will put a very simple thing. Oh, who's my mapper? Who's my reducer? What is the input data format, output data format? In mapper, you will write the logic saying what should I do with one record at a time. And in reducer, you will write the logic which will say what you should do with one group at a time. Okay. Now, if this is the logic, there you will see a lot of things in the code right now. With that, today what we will do is I will show you 4 code samples. How many code samples? 4 MapReduce programs. In every MapReduce program, you'll have a driver, you'll have a mapper, and you'll have a reducer. Now you can also have advanced things like chaining, where you say that driver can have 2 different mappers, and then they will call the reducer. All these complex workflows are possible. Okay, so it's like you can go on making it more and more complicated, but the good practice is keep it simple by having multiple MapReduce programs and call them as a workflow. So what I'm trying to say is, can I code like mapper, then reducer, then let's say one more reducer, for example? Yes, you can, but a good practice will be MapReduce, and then chain them as a workflow. That will make your code very, very maintainable. Okay. So let's today we will look at 4 examples. So now we've understood how this works. We will now jump into the code. First thing we'll talk about is how to write a word count program. Okay, what we just did now. We will look at one more example, which is how to aggregate. Same thing, like word count is aggregation, this is also aggregation. We will then see how to do joins. So there'll be two type of joins we will see: joins in mapper and joins in reducer. These are the 4 code samples we will see. So let's go ahead and do that. Now it's time to basically look at one piece of code. Okay. So on LMS, let's say everything is available, you can download. Now just help me out. From LMS at download, there are, what you call Hadoop code files. So there is writing MapReduce program, multiple input format, joining, how to aggregate data. These are some of the files. So I get word count and my code is in source. That's Java code. Let's talk of code. I open in gedit and the first thing you say is, no man, how will I in real world write it in Notepad? So you should not. You should actually use a tool called as Eclipse. So why don't we directly look at it in Eclipse? All you need to do is open your what you call this thing. So let's start from a fresh slate. So I open Eclipse. Eclipse is saying me that, Mr. Ravi, I will look for your code. I will look for your code in home training workspace. So you better have your code there, because that's where I'll point to. I go to my home training and workspace and I realize that there is nothing. There is some file called intellipaat.txt. Let's get away from that also. So Eclipse is saying that, dude, I am expecting your code or new projects will be created at workspace. And in the background, I see workspace is completely empty. So we are starting with 0. Okay. I go to workspace. Okay. So how do I create a project right now? So one way is I can directly create a project from here and I can, build a file. I can do that also. Or I can take this project that we've got, okay, and take this word count project. So I'm just taking this and putting it inside workspace. Okay, so there are some additional files, ignore them right now. Okay, and I will simply say that I would want to create a new Java project. It says, where is the code? I'll say word count. And this guy says, yes, I realize there is word count. When I say finish, okay, so there are some files I see, but God, there are some errors also. So here you go. This is trainer's code. Looks to be pretty good. Problem is that there are so many errors. What do you do right now? The errors are because you have never got the libraries. So it's time to get the libraries. So let's look at it. There are good amount of errors. Let's say 48. Let's bring the library one by one. So we say Java build path, add external jars, user lib Hadoop, and get all the Hadoop libraries. Once you come in, some errors will reduce. So there are actually less errors right now. Now we need to get libraries from MapReduce also. Add external jars, lib, MapReduce. Perfect. So some errors are less. Let's see what is the error that is still there. There is something called generic options parser that appears to be a pain. Now let's see what you are supposed to do. First thing, you've got MapReduce, but you are supposed to deploy your code on Yarn. So you should also have the Yarn libraries. and you should also have Hadoop lib in these libraries. So I've created all the libraries, and so good, all errors are gone. We are happy, pretty happy, errors are gone. So let's say code is given to you, we've not got into code, but you imported the library and it is code free, right? It's like error free right now. So let's say export. So I'm showing you how to bundle it now. First, we'll jump into code later. I say jar, and I'll say put it in home training word count.jar. I say finish. It says there are some issues. I'll say okay, ignore them. So I see this jar called as word count.jar. This is just now created by me. This is just now created by me. Let's run this. Hadoop jar word count.jar. Now my package is com.hadoop.wordCount. com.hadoop.wordCount. Okay. I am running it with input data, and I'm running with a new folder called as, or let's run with output, but we should clear the output. So hdfs dfs ls. I will delete the output folder. hdfs dfs rm-r output. So I've deleted output. So let's run this job. It says it was expecting output folder. I said no problem, take it. So the job has got submitted. So once this job succeeds, you know how to see output. And we'll pause for a minute to document the steps for you so that you see that this pointers will be there for you to see. Okay. So let's first talk about how to create the code. So first one, take the code from LMS, unzip it, take the word count folder and put it in workspace. Open Eclipse. So good. Say new Java project. Include libraries from user lib Hadoop, user lib Hadoop lib, Hadoop map reduce, Hadoop. Yeah. Export the code as jar file, run the jar file, bang, you are done. Okay. So how to create a code? This is option 1. This is option 1. There is other way also, we'll see that. We will see that. So then this is your option 1. Okay. Now option 2. Option 2. So this is called using Eclipse. So using Eclipse. Option 2 is using a build tool called Ant. Let's see what do we mean with that. Let's see what do we mean with that. Okay, so we will do this and then we will jump into the code. So we'll pause for questions and then we'll jump into the code. Now I don't want to use Eclipse. No, I'm not comfortable with that. You know, I am a guy who's, let's say, very comfortable with build tools. So don't worry, Intellipaat has already taken care of that. In the word count folder, okay, this code is ready. I'm supposed to build a jar file, but jar is already there. Let's remove, we'll see it. So you use a tool called as Ant. Ant is a tool that will create a jar file based on the steps. Let's look at it. It will be simple. Okay. Just to prove that I am doing it differently, I will do completely different setup here. So let's look at it carefully. I'm saying mkdir America. This directory is nowhere I have created in front of you. Then I say cp Hadoop code files, writing MapReduce program, word count. I want to copy this entire folder in America folder. So I'm not using Eclipse anymore, okay? I'm copying it in America. It's done. Look at it. lsltr America. You see a folder called as word count. Now I say cd America lsltr word count. What man, this jar file is already ready for me. So I will delete this jar file in front of you. I'll say rm-r word count of jar. So now you see there is no jar file. So Ant is a utility that you install and just go to word count folder and run this command Ant. And Ant has successfully built a jar file for me. So this was like from the command line. Now what I do is, it is simple. I'll say I want to run this word count.jar. I'm directly running word count.jar, which we created right now. But instead of output, I'll give another folder Ant. Okay, so output came. Just to prove HDFS DFS LS, I'll see out underscore. So let's document. If you want to use a build tool, first in your VM, just run a command. First, install Ant. Use a command sudo yum install Ant. Copy word count folder from the LMS code files to say a new location of your choice. We did it in America. Now there, just do cd word count and delete existing jar. Run Ant command. Bang, your jar is ready. Run your code. Now Eclipse is very easy, you know, it's all automated. But now the question would be that, can I have this Ant based stuff? I have already given you all the steps, but if you want more details, each program has a README file for deployment. So if you go to this Hadoop code files in word count, there is a proper readme.txt that will tell you how to do it. Make sure your folder paths are correct. That is something you can take care of. This explains you the logic of the program, and at the very end it tells you how to run it also. It tells you that exact steps also. Okay, so this is README. If you're doing from Eclipse, that is easy, just import a project that you don't need a documentation. But if you're doing it from the background, this is what you should be doing. So I've documented both the steps. So at least one thing is clear. At this moment, we are clear with how code gets submitted, how code gets bundled from Eclipse as well as from command line using and how to code MapReduce. And now it's time to talk about how do you code it. Now when it comes to how to code it, every MapReduce program will have three files: driver, mapper, and reducer. Okay. Okay. So here we go, and that's where we have our word count program. And as said, we have one word count.java, but there'll be three classes in that. So let's first see all three classes before we jump. So this is my reducer class. I guess in case you're not able to see, let me increase the font size. Preferences. So we go for editors, text editors, colors and fonts, edit, and let's go for a bigger font, 14. So this is bigger. So this is my word count, which is my driver class. This is some reducer, which is my reducer class. And this tokenizer mapper is my mapper. So in this you find three Java classes. Okay. So word count happens to be my driver class. Within that I have a mapper, and within that I have a reducer. So we are clear. Let's see how does it go. So the first thing that happens is it goes to main. That's where Java code starts. That's where Java code starts. Now the first thing we are calling is, we are saying that read the configuration. Okay, that means where is the name node and all that. So if you recall today morning, today first thing we saw is that etc Hadoop conf folder. So this basically is reading that particular configuration folder, and it is also checking if there are any other arguments that we've got from the user, some customization that user has given, for example. Okay. All right, so read the configuration and see if there are some other configurations like input path, output path, and all that stuff. Okay. Now, what we're looking at if the arguments given by the user, if they are not equal to 2, then job should fail. That means we are expecting the user to give us input path and output path, and if we don't get it, I would request it to fail. Let's look at it here. So I'm running this job and I don't give output. It clearly says the usage is word count in and out. So that's exactly what it says. So then it starts the job class. Job is basically now reading the configuration and applying it. And here we are saying that my mapper class is mapper. My combiner is going to be the reducer class only, and then there is a reducer class. So we are calling our combiner. Set jar by class is basically saying that this is our main class. So the jar file should basically look for this particular main class. So here we are good. So we've informed our framework that these are the classes that will be called. Now let's talk about the output format. Now we are saying that what we are saying is, so first here we are specifying that input path and output path is specified. We are saying that both mapper and reducer, their output is text comma integer. Let's carefully understand. Let's carefully understand. So we were looking at the output folder, right? hdfs cat output slash part r00000. So this is text. This is text comma integer. So we are saying that our mapper output is word comma 1 and our reducer output is also word comma integer. So we are saying our output key class is text and our output value class is int writable. Int writable is nothing but integer which is serializable. Integer which is serializable. So there is a class for that. And once we've set all that, we are submitting the job. We are submitting the job. So if you see, our driver class has no business logic. It just knows what is mapper, what is reducer, and it simply calls it. It just knows mapper and reducer and it simply calls it. So far we've not done anything with the business logic. Business logic will come later. So my driver is ready. And yes, we agree that driver is not business logic. It is just setting expectation. Oh, this is my mapper, this is my reducer, this is my input type, this is my output type, blah, blah, blah. Now let's go to the mapper. Now mapper is our smart guy who will work on one record at a time. One record at a time. When I say one record at a time, what do I mean? Let's talk of that. When I say one record at a time, it is hdfs dfs cat input Intellipaat.txt. Am I missing something? ls input. Okay, it's got the spelling wrong. Intellipaat dot. Why am I doing ls? I should do cat. So one record means Intellipaat is one of the very first companies who got into big data. Okay, so this map will take one record at a time. That means this is my record. And in the notepad file or text file, this starts with a byte offset 0. Okay, so it says this is an object which is key and the value is this entire string. Intellipaat was the very first company or is one of the very first company that got into big data. Now inside, if you see, we are tokenizing this value. We are tokenizing this value. That means this string is now tokenized into so it's tokenized as so that first record is broken into bunch of strings. Okay, so Intellipaat is one of the very first companies now broken into this. Now we are iterating it. While the iterator has more tokens, please go to the next token and emit word comma 1. Now what is 1? It is already defined here. 1 is this integer 1. That means the output of mapper will look like Intellipaat comma 1 is comma 1, 1, the comma 1, the very comma 1, first comma 1. Nice. Now shuffle and sort is part of the framework. We don't really have to code. We just have to code the reducer. So after shuffle and sort, the input might look like big comma 1 1 1 1 because there were 4 sentences, and data comma 1 1 1 1. Nice. Now reducer takes one bucket at a time. That means it takes big comma 1 1 1 1. Key is text and an iterable on integers. It starts sum from 0. It says 1 plus 1 plus 1 plus 1, and bang, the output is big comma 4. That's my final output, big comma 4. My friends, look at this, hdfs dfs cat output slash part r big comma 4. Why it is 4? Because in my input comma big is 4 times. That's how your word count is coded. Like this, any map reduce code can be coded. Any map reduce code could be coded. That's how it looks like. Okay, that was first what you call code. Like this, there are what you call multiple assignments, and they will more or less follow the same trajectory. So let's proceed and do one more project. We go again. Again, we are interested in looking at the code right now. Okay, so the job will run, readme is there. Let's look at how to aggregate the data. So the project is time diff, and we are interested in looking at the code right now. We know how to run it, so that's fine, and code is working, so that's okay. We need to see the code right now. Let's see what we're doing. So I say cp Hadoop code files, how to aggregate time diff. I will copy this in workspace so that I can show this in Eclipse. That's the idea, right? So I say workspace, life is good. Say programming, Eclipse. So we'll close word count. I'll start a new project, new Java project, time diff, finish. And now you know how to get rid of errors and all, but I'll just do it just to, you know, steer clear of it. Libraries, add external jars. Same process which you've already seen. Okay. So now what we are trying to do here. So let's carefully understand this. Again, you want to understand it, very simple. Just go inside and there is a proper readme.txt. So it shows how to run, but the idea is this is my input data where I have some users. I have their start time and end time. I just want to know how much time they spent. Let's carefully look at it. It's a very simple thing, okay? There is a user called Ram. He started at 12 and Ram stopped at 13. So 13 minus 12 Ram is 1. Dell. Started at 12, ended at 14. So we are just doing the same word count thing, but we are just performing another operation. So Dell is 2 and money guy is 2. All good. Now let's look at the code. So again, we have our mapper, we have reducer, and we have main class. So same thing, we are setting up everybody just like previous thing. In my mapper, my output is username comma time, username comma time. So here my output will look like this. My output actually from mapper will look like this. Now if you carefully see, so I'm putting this full-fledged thing so that you get the whole idea. But I'm only writing name, which is key, and the time as value. So I'm not writing start and end. Let's say I'm not interested in it right now. That's why I've said I want to only emit user comma time. I'm not interested in start and stop. That's how I code it, simple as that. Nothing like I can push it. It's Java, but I'm just pushing username comma this. Now to reducer, the input, there'll be 3 buckets. First one will be this, which may look like 10, 12 or 12, 10, doesn't really matter. For second one, it will look like Dell 12, 14. And for third, it will look like RAM 13, 12. Doesn't really matter. Here we are saying that take any first value as whatever you get and the other value as start. So first will be start, second will be stop, and finally we are just subtracting by doing abstract. So my output will be, I'm using the absolute value, my output will be minus an absolute value, so my output is 2, 2. So that's how you write your map reduce code. Map reduce, divide, conquer, performing a join. Let's say here, this actually is a classical example of we are kind of performing a join. Okay. So I say cp-r Hadoop code files, multiple input formats, multiple to workspace. Okay, so it's multiple input. We go to Eclipse. So this is slightly strange and slightly interesting because, so we'll ignore the errors, you know how to fix them. Here what we are doing is, there are multiple mappers. There is one mapper that reads customer details and there is another one which is reading delivery status. So there are 2 mappers in it and there is one reducer in it. Okay. So here what we do is, I say multiple inputs for this particular input path, call customer detail mapper. For this input path, called delivery status mapper. So first 2 mapper will run, one for one file, other for other file, and then you call the reducer where you are performing a join. So let's pay attention to it. From customer side, I am writing cell number, comma, let's say customer name, From delivery side, again I'm writing cell, comma delivery code. And here based on cell, I am giving away customer name and delivery report. So this is a classic join. Let me draw this for you. So the flow looks like mapper, mapper, and let's say reducer. So this mapper, he reads customer data, and this mapper reads delivery data. So this is complicated in terms of, you can always have multiple mappers like that. Now this guy emits, let's say, customer ID, comma, some details, and this guy also emits CID, comma, some details. What we get here is CID, comma, details 1, comma, details 2, and here we can emit details 1, comma, details 2. So this is how you will perform a join. Let's look at the readme part. This will give you complete idea. So like this, you will always have what you call more and more examples on internet. You can find thousands of them. So I have customer data, which is this, and I have mobile status, which is this. Now what we do is, one mapper will extract ID and name, second will get this, and finally I am getting the status as a join, which is customer and does he have a phone or not, let's just say. Okay. So like this, we've seen the basic constructs of MapReduce and everything that is around it. We've gone through the real code. The use case that I showed was actually doing a join. Now for join, you've got to have the key, which is same. So let's understand what we are trying to say. There are two ways to achieve it. Two ways to achieve this separate data. So let's say first is a easier case. I have a file from what you call RDBMS that came as CSV, which had, let's say, user ID and let's say XYZ info. Another file I got from JSON, the JSON structure will have user ID and again ABC. So of course one way to tackle is my mapper will be called here. My mapper will be called here. Okay. And it will emit the same key and then you go to the reducer. Now, this will work only if you have the key. So formats are different, but they still have a key. Now, if you have completely separate data sets, you will have to still find a way to get a key that is for you to get it. But let's take a simple example. Okay. I'm doing some XYZ analysis on cameras. Now for those, you know what you call, then I have some images. Okay, and in that images I have quality of images. Let's say there is a way I calculate quality. So I have cameras, their specifics, images, and let's say their pricing information. Let's say my use case says that finally I want to know which is best camera at every quality point. So now this use case is pretty much very much like ETL, right? So I get my data into Hadoop. This is my E. This is my E. Then I may have to write separate MapReduce code to get what I want and maybe dump a key inside. So I may have to manufacture a key inside. So this will be a separate T, separate T, separate T, which is completely independent. But when I write a T, I have to somehow make sure that now I get the key right. And then I'll have to perform the final join and then do a L. So the point is, the example that I showed, keys were ready-made there, but sometimes you don't get keys ready-made. That's where you require developers who will do E. Your process of T is to make sure that data has the same key, just like a normal traditional BI. You have dimensions and facts, you're wiring them up. It will be a tedious effort because let's say formats are like, for example, here you actually got images. In this case T, you are extracting information from an image, analyzing it, and then basically wiring it together. So sometimes this will work where the key is ready-made and you directly do this, and sometimes you'll have to write independent jobs and eventually wire them together to get what you want. Are we clear with that? But yeah, eventually your job is to get the keys together, otherwise you'll not get your output. That's how your ETL facts and dimensions is what you create, right? That's exactly that way. Hadoop ecosystem. So let's start. So let's take a small example just to drive the whole thing. So let's say you have wrong design, but let's just say this is iPhone. This is iPhone. So sorry for the drawing, but well, let's just say this is iPhone. Okay, so we've got iPhone. When you say iPhone, what does iPhone really mean? What does Apple give you? It gives you the hardware, plus it gives you iOS, that's the software. Now this is basically your phone. Let's just say that this is your core phone. Along with that, now this is what you get when you buy a phone, but there are few other things that are related to iPhone, but that are not part of your core phone. One of course is apps. So you buy them, you install them, that's your wish, but that you don't get directly with your phone. Accessories. So let's just say screen guard, cover and stuff like that. And let's say there are some services like, you know, think of it like Spotify, music services and so on and so forth. So these three things are not part of core Hadoop or core, you know, what you call iPhone, but they are kind of ecosystem. Okay. Now, very similarly, when you say core Hadoop, what you get is HDFS yarn and MapReduce. So let's say you call up your friend and say, hey man, I have installed Core Hadoop. That means you have HDFS, yarn and MapReduce, and we've kind of covered that in a lot of detail. But my friends, that's not all. That is not all. Why that is not all? Well, just like a phone, there is a supporting ecosystem. You have bunch of applications that are there to solve some problems and add to this, and that is called Hadoop ecosystem. That is called Hadoop ecosystem. So let's just say that what apps are to iPhone or any phone, ecosystem projects are to Hadoop. Okay, so let's proceed with this right now. Very similarly, Hadoop has ecosystem apps. Let's see some of the apps. If I want to get data from RDBMS to Hadoop, the ecosystem project that is there, or the app that I should be installing, is called as Scoop. It is called as Scoop. If I want to get data from real-time logs, the ecosystem app is Flow. If I want to, so this is my ingestion tool. If I want to process or transform this data and process, I have Hive and I have Pig. Just like Hive, there is another what you call processing layer or SQL engine query called as Impala. Then there is other processing framework called as Spark. Okay, so whatever is in black, it's an ecosystem project. So my point is, my friends, when I say I have installed Core Hadoop, that means I have only installed HDFS, MapReduce and yarn. Everything else has to be installed by me. Okay, so these are some apps. Everything that you see in black is ecosystem projects. Now, after our Core Hadoop is done, today's agenda is just to discuss all or introduction to all these ecosystem projects. That's the real idea. Okay, so let's proceed now. So here is the idea. Intensity will start when you go deep into each and every ecosystem project. So, okay, Hadoop has ecosystem projects. Can you list down some of them? Well, I'm going to list down most of them. But before I do that, note to you. So this is a small note from my side to you. Every app on your phone has a specific purpose. Like I cannot book my movie tickets from Facebook. I cannot book, let's say, my restaurant table from Uber, for example. Okay, so every app has a specific purpose. Very similarly, every ecosystem project has a specific use case. So with that, let's talk about each one of them. So let's talk about most popular. Okay, so first is Scoop, which is RDBMS to Hadoop or Hadoop to RDBMS. Second is Flume, real-time logs to Hadoop. Third is Oozie, which is workflows for Hadoop. Fourth is Pig, kind of PL/SQL on Hadoop. Fifth is Hive, which is SQL on Hadoop. Impala, which is SQL on Hadoop, just that it's faster than Hive but does not have failover capability. That means even if one slave fails, job will have to be resubmitted. So that's one major difference. Spark, just think of it this way, it's a new framework that is much faster than MapReduce. U, it's Hadoop on browser. Sentry, ACL for Hive tables, that is grant, insert, select kind of layer on Hive tables, and so on. So the list goes on. So the list goes on. You'll have a couple of more here and there, but these are some of them. Now, what we are going to discuss here is the first five: Scoop, Flume, Oozie, Pig, and Hive. U is nothing but a browser-based application, and Sentry, again, nothing's to be covered from the developer perspective because it's just grant, insert, select to user this. So for admins, they need to set up Sentry separately. That's the idea. So Impala is just like Hive. Spark, we'll just touch base upon it, but we'll go fairly deep in the courses ahead. U is Hadoop on browser, and Sentry is basically the ACL layer, access control list layer. So now the next thing we do is let's understand what we are supposed to do today. So I'm basically building this for you guys. Here we have so let's understand the flow. Let's understand the flow very, very smoothly. First, at the very bottom, guys, you have a Windows machine. On Windows machine, you have CentOS. And yes, there are 6 services that are installed. The services are name node, data node, secondary name node, okay, resource manager, node manager, and job history server. Now what I want is, okay, so we understood that there are 5 ecosystem projects. They have all their purposes. and we've kind of introduced them. We will first on this VM install Scoop. What is Scoop there for? So let me install, let's say, Scoop here. Once I install Scoop on my VM, let's say I have MySQL, let's say. So Scoop will help me get data from RDBMS and dump it into HDFS. So that is our first demonstration today. Okay. So we've seen the ecosystem projects. So Scoop is basically a guy who can, let's say, get data from RDBMS and put it in Hadoop. It is all good. Once my data is in Hadoop, okay, what I'll do is to process that data. Of course, one way to do it is MapReduce. So we will install Hive and we will install Pig, and we will find a way to analyze that data. Today's agenda is to see, oh, there are 5-6 ecosystem projects. How do you really play with them? So the first one is Scoop. I'll get data from MySQL, put it into Hadoop. Perfect. Second is being able to write some queries in Hive and Pig. Okay. So let's start with that. Okay. Now, just to ensure that before we go deep, you should have some things installed on your laptop so that you are ready. Okay. So now I'm going to basically demonstrate the whole thing to you. So our first agenda is, can we take data from MySQL and dump it into Hadoop? Can we take data from MySQL and dump it into Hadoop? Can we then, do some processing some any other data on Pig and let's say Hive? Let's look at that. So the VM is firing up. Okay, we are in here. All right. So let's carefully understand what we are trying to do. Let's talk about the main thing. So our main agenda right now is get data from MySQL and let's say query that in Scoop. Get data in MySQL and query that in Scoop. So first you're supposed to install Scoop. Scoop will get data from RDBMS to Hadoop. Scoop will get data from RDBMS to Hadoop. So let's do that now. First thing, Mr. Trainer, why don't you prove us that MySQL is there? So let's do that. MySQL -u root -p, that's password, and it is root. Oops, it says cannot connect to MySQL. And the error is so very clear. It says I cannot get through MySQL on the socket. Oh, that means MySQL is not running. How do I prove that? Sudo service MySQL d status. And this guy says, boss, MySQL is not even running. So I have not even got to Hadoop. I'm just making sure that RDBMS is up. If you're not comfortable with MySQL in real world, I'm sure you're comfortable with some database, be it SQL Server, be it Oracle, it's fine. So let's start MySQL. To start MySQL, the command is sudo service MySQL d start. Sudo service MySQL d start. Okay. So let me just put this command somewhere for you guys so that so the first command is start MySQL. Second is, do you have data in MySQL? MySQL -u root -p root. I'm in MySQL. I say show databases. And this guy clearly shows training DBs there, which is amazing. So I'll say use training_DB. And I say show tables. So within training DB, there is one database called as user_log. Within training DB, there is one database user_log. So from our flow perspective, one thing is dead sure that yes man, MySQL is there and we have verified it. Let me change the color here. Yes, MySQL is there. It is healthy and it has a database called training DB and a table called user_log. Second is Scoop installed? The document tells you how to install Scoop, so you don't have to worry. So I have installed Scoop here. When I run, it says try Scoop help for usage. That means Scoop is installed. If it was not installed, I would have got an error command not found, but it is perfectly installed. So now let's play with Scoop. Let's play with Scoop. Let's do some simple stuff. So I'm not importing the data so far. I am just doing some simple stuff. So I'm saying Scoop list databases connect JDBC MySQL localhost training_DB username root password root. I am just checking the list of databases. When I run this, Scoop is running and it says yes, there are 4 databases in MySQL: information schema, test, MySQL and training_DB. Or let me verify this for you, okay, so that this is clear. MySQL -u root show databases. 4 databases, 4 databases. That means Scoop is good. Next thing I do is I say show me the tables within training DB. Instead of list databases, I'm saying list tables. So it says there is one table user_log. So why don't we see it here? Use training_DB show tables. It is indeed user_log. So looks like everything is good. Can we now import the data? Can we now import the data using Scoop? Before that, let me show you a snapshot here. HDFS DFS LS as of now has 3 folders and I'm going to delete all of them so that it's very, very clear to you. HDFS DFS LS, it's blank. Oops. Sorry. So HDFS DFS LS is completely blank. Let's do our main thing right now. We will use Scoop and we'll say Scoop import connect to this training DB username password, and I'll say that the table that I want is user_log. Fields should be terminated by by tab. Now Scoop internally will generate a MapReduce job, and what I want is I just want it to run one mapper. it's a small setup, so I just want to have, it's a small setup. So all I just want to do is, I just want to make one connection to RDBMS. I don't want to make multiple connections. By default, Scoop will make 4 connections. I just want to have one connection. Okay. So I'll say table user underscore log fields terminated by tab okay, and -m1, and I say bang, it is running. Let me prove it here. We have nothing in HDFS DFSLS, so it's submitting a MapReduce job. So the job is done. Carefully look at it. It got 50,000 records. It got 50,000 records. So let's match everything. I say select count of star from user underscore log 50,000. HDFS DFSLS. Oh, user log is created. Within that, I see one output file, which is, this is the output. But let's carefully understand what I'm trying to do. HDFS DFS cat. I want to count the number of records. So that's WC, so number of lines in a file, WC -L, and it's 50,000. You're free to do a cat to see this 50,000 records, and you are free to do a select star from user underscore log. So we've successfully got our data from MySQL to Hadoop. So that's our demonstration one. Now I'm sure that the feeling would be that probably, oh yeah, this is very basic. Yes, of course, today's idea is to be having it basic, because as I said, today level 1 of course is completing. It is just to introduce you to the whole thing. It's just to introduce you to the whole thing, and you go very, very deep into each one of them. Okay, but that's the general idea of Scoop. Okay. Now with that, now that we've got our data in Scoop, I want to write a SQL query on top of it. Okay, so Hive will let you create tables and basically let you perform analysis on it. Okay, so now we will look at how to write SQL queries in Hadoop. But how Hive internally works, we will go very, very deep in the next week. So just stay parked, stay put. Everything that we see, we will have a lot of details on it. The next part of our introduction is Hive. Okay, can we write SQL queries on the same data? Can we write SQL queries on the same data? So what I'm trying to say is HDFS DFS I see user log. Now on user log, at user log, I see this part M000 stuff, which is the file. Now, can I create a table on top of it and write my SQL query? Can I create a table on top of it and write my SQL query? See, what I'm trying to get to is, guys, this is a normal text file. On text file, I cannot say select star. So Hive will let you do that. Right now the point is, oh, I have got some data and I am unfortunately not good at Java. So I don't know how to write MapReduce code. Can I do some magic so that this file that I got, which is let's say 50,000 records, I want to perform some analysis, but I'm very good at SQL. So the tool I will use is Hive. The tool that I will use is Hive. And now we are going to see how will Hive do that. How will Hive do that? Okay. And how is internally this whole thing is working, how this whole setup is there, next week is all for that. And we will go very deep into Hive. So this is like the setup part that you'll be doing on your VM. Okay. Now, all we need to do is we need to go to Hive. Okay. Wow. So I'm on Hive prompt and I say show tables. Oops, there is only one dummy table. Let's drop that. Sorry. It's drop table dummy. So now when I say show tables, Hive does not show me any tables. Okay. My agenda is that the file that I got from Scoop, can I write a SQL query on that? Right now, that's my agenda. And we will do that right now. Okay. Right now, we will just look at the usage. So think of it this way. I am right now explaining features of a car and how to drive a car. Okay. Right now, just look at, oh, how to drive a car and just enjoy that part. So let's jump. Now what we do is, I run a simple create statement. So what I do is I say in Hive, let me exit, say Hive. Now carefully look at it, guys. I say create table user underscore log, where the first field is country and that happens to be string. The second field is IP address and that happens to be string. Each row is a single record, so we say row format delimited fields terminated by very important tab. The data that we got from Scoop, we only said that the data should be delimited by tab. That's why I have to respect that delimiter in Hive also, that the data that came is tab delimited. Had I made it comma here, I should have been putting a comma here because the data is delimited that way. So now I am saying yes, the data is in, and yes, it is separated by tab and it is very well stored as text file. Wow. So I have created my table. This looks perfect. This looks perfect. So the table is created. I say show tables and I say user log table is there. But I have just created a table. I have not loaded the data. Select star from user underscore log. It says there are 0 records there. So why don't we load the data? So let's load the data. Now for data, we are loading exactly the same file that we got using Scoop. I'm just loading exactly same file. I am saying load data in path user training user underscore log part m, okay, into table user underscore log. So I'm loading this data. So the data is loaded. Let's run some queries. select star from user underscore log. This shows the whole thing. Let's get the count by country. Select country comma count of 1, it's as good as count of star, from user underscore log group by country. So it submits a MapReduce job in the background, so I don't have to learn Java. It is converted to MapReduce. So the job is running. And this gives you count by country. So this data was country and IP address. You're simply getting country comma the count of the requests. The assignment is about a data that pertains to movies. A data that pertains to movies. So the data is called movie lengths. Okay. And here you are supposed to create a table, load the data, and perform joins. Now this data is already what you call given to you on LMS. So this is your data, ML100K. Just to explain this data, this ML100K is basically bunch of files which are there. They have different delimiters and all that. So your job is to first create the tables, load them, and perform the analysis. So I'm going to run you through the steps, and this is your assignment. Okay. Create table u underscore data blah blah blah. Then load it, but this time you're loading it from a local file. So give the correct path wherever you are putting it in. Then you are creating another table called as u underscore log user. Load it. Then you practice joins and whatever is required. So that's your assignment. That's your assignment. Okay. So this was a quick introduction to Hive. We've done introduction to Hive. We've seen how to get data from MySQL to Hadoop. We've seen how to query that what you call in Hive. So let's see what hands-on document will say for us. So we are done with Hive. Okay. On through the week. Now Pig is another way to do things instead of Hive, but Pig is more expressive. It is more like PLSQL. Okay. Scoop and Flume is like E. Hive is like L. That's where you load, and transformation will happen in Pig. Okay. So you install Pig. Now the way this assignment will work for you is, just to give an example, I have written 6 codes for you. I have written 6 Pig programs for you, and you have an assignment to do the 7th one. You have an assignment to do 7th one. Okay. So now there are a couple of programs on Pig. We will directly walk through the code because there is nothing else to explain. Pig is just like gets converted to MapReduce, just that it's more expressive. So I've given you some programs. You are supposed to do one assignment over the weekend. Okay. So let's carefully look at it. So on your what you call e-learning site, you will get this. I extract my Pig programs here. So we've written 6 Pig programs. Okay, they are very, very simple. Let's look at a couple of them. Okay. So let's say we will look at the first one, Pig with schema. Here what we are doing is, we are initializing, let me see if I can find a way to increase the font size. How do I increase font size? Preferences, fonts. Where is the size? No space 10. Okay. 16 would be good. Yeah, nice. Let's go very comfortably and look at it. So I'm saying that I want to have my first, think of it like a variable. Again, we'll go very deep into it in the sessions to come. Today is just a starting. We say weblogs load user training weblogs webstar using pig storage. It's a library that you call functions. We will see that in the next class using a delimiter called as tab. Now in my data, I am specifying that there are, let's say, 18 fields, and I'm kind of declaring them. That my first field is this, second is this, third is this, fourth is this, and then I can perform any operation. In this first example, I'm just taking that data and dumping it on screen. Okay. So this is pig with schema where I'm defining a schema and I'm dumping it. Let's say if I want to do something else. Let's say I want to filter it. So I'll use something called pig with schema and filter. So what I'm going to do is I will load the data, but I will write a code which says career visitors filter weblogs by URI is equal to careers, and then dump it on screen. So I can either call it as dump and store. All you need to look at is that a Hive is more like SQL and this is more like PLSQL or more expressive. This is very close to what scripting would look like. Okay. So I can filter. I can also do a group by. So I'm saying group by something and generate the count. So basically pig is more like PLSQL, and we will have good 6 hours of coverage on that. We will go very deep. Now let's quickly look at running one or two of it. So we will basically go very deep understanding how we are running this program, and then there is an assignment for you. So let's do that. So first thing is, let's say I want to filter all the users who are coming for careers website. Let's just say, boss, but where is the data? Oh, where is the data? What is the data? I don't even know that. So let's carefully look at it. We are saying that we expect data in a folder called as user training weblogs, and there has to be a file called web. How will it work, man? We don't even have the data. Well, it's our job to build it. Let's do that. So let's go to HDFS and say HDFS DFS ls. Do we have a folder called as weblogs? No. So it's our job to create it. So we say HDFS DFS mkdir weblogs bang. So the folder is created. We are all in good shape. But where is the data? Now the data is also given to you. Okay, it's there on the learning site. And this is your file, which is weblogs. So the file is weblogs parse.txt. We will put this file, okay, inside HDFS. So let me just copy this file to my training folder so that becomes easier for me to get it. So I'll say places. In my home folder, I'm putting this file called weblogs parse.txt. HDFS DFS put weblogs parse.txt in weblogs, the folder I just created in HDFS, and we are in good shape right now. HDFS DFS ls weblogs, and this shows me that particular file. So there are good amount of records. How does this file look like? Well, let's open it. It's a big file. So our first thing is IP address. Second is the whole date. Then for analysis, we've again broken the whole date, 3 June, all that. The time zone, okay. Get, so this was the get request. What URL did the user visit? 200 is a response code. In the web, 200 means that the request was successful. 0 is something based on the data that we have. The user came from Mozilla, he was using Windows operating system, and so on and so forth. So this is my one record. And as a developer, I have already specified pig that my first thing is IP, second is full request, third is day, month, month number, year, hour, minute, second, time zone, verb, URI, HTTP status code, bytes returned, referrer, and user agent. So now I have decided that this is my schema. In this program, I want to filter every user who came for a URI careers. So basically the URI should basically have careers as the URL. Only then we would want to filter that. So let's run this program now. Let's run this program. It is going to be dead simple. So now where is Pig Programs for me right now? Pig Programs is in my downloads folder. Just to simplify it, okay, I will put them in my training folder. That's my home folder. Just to simplify, okay, it's just a folder copy, nothing else. So my PWD is home training. I said pig programs, pig with schema and filter. So I want to run the pig program which will filter everything by careers. Run this job, submit some MapReduce job. Runs a big time job, let's see. Now we've said that we want output to be dumped. Okay, there is other function called store. We'll be looking at that in detail. But here is the record that came. So like this, this is our output, let's say. Couple of records, we'll just look at it. 683.41.613.5 was our IP. This was our whole date, our time zone, the date broken. It was a GET request, and the URL that user came for was careers. Okay, so we've got all the requests that had careers in them. Like this, I have given you 6 programs. So you are free to run them, practice them, do what you want. And the 7th one is an assignment for you. So you've written all the 6 programs, understood the code, which is very simple, nothing, filter, group by, all that. Review all the 6 programs and write the 7th one. The 7th one should read the log file and give output as IP, month, year, and visits. Okay, IP, month, year, and visits for that IP address. So that is pig. Okay, can we do it? Yes. Will you do it? Generally no. Generally no. Okay. You know, again, probably I won't be able to. I wanted to show one slide to explain what is what you call. If I wanted to just show one diagram for pig, this is the favorite diagram that you say. I get data from multiple sources. I'll have bunch of pig jobs that may validate errors, fix errors, encode values, and load it in a warehouse. In Hadoop, the warehouse is Hive. So let me take a screen snap of it so that I can explain what I'm trying to convey here. Okay, I take this, it's a capture, and this is E. Okay, this is P, and this is L. Now, having said that, does pig allow me to connect to Hive tables? Yes, absolutely possible. But in real world, you will not normally see people doing that. So answer is yes. But when somebody is doing or you want to do it, ask yourself a couple of times in production level that, do I really need to do that? That's the point I'm making. But yes, it's possible. Don't worry about that. Hive and Pig are like SQL and PL SQL. They'll have bunch of their own libraries. Okay, and there is community which will have a lot of defined functions. But let's say something is not being done for you. Let's say be it Hive or Pig, you don't have a function to calculate a shipping cost. I can write that in Java and Python. You can call that as a user defined function. You can call that as a user defined function. So what I'm trying to say is, be it Hive or be it Pig. Okay, let's just put it this way. Let's say Pig has, for example, 100 functions, and from web you can get another library with another 10,000 functions. So that's, I think you'll easily find something called as piggybank.jar. So this will have basically some more functions for you in Pig. Same is the case with, let's say, Hive. Just like SQL, it has some functions ready-made for you. Just call them. But let's say your organization has a peculiar use case which has to be done, Okay. So for example, you would want to pass a code, and based on that you are supposed to get a full value, for example, that your organization only knows. Take a simple example. Your organization has device codes where you get device code and then I'll tell you the actual device, for example. So let's say Ravi will code something like a pig UDF for device name.java .jar, and I will expose a function to you called as get device, for example. So whenever you're transforming, you pass one record, I will code that in Java and give you the output, just like a service. So this is called as user defined function. Same will be for Hive. Now, what you're doing is using Scoop to you're loading that HDFS in Hive and writing query. Is that clear? Very straightforward exercise, completely self-explanatory. So if you look at exercise 5, it's you have MySQL where there is some data. It's fine. You are getting that data out using Scoop and dumping it to Hadoop file system. Fantastic. Once you get that data in Hadoop file system, you are using Hive to basically load that data in Hive and what do you call query that data using SQL queries. Okay. Now it's a self-explanatory exercise. You would not need help. Steps are fairly clear. What I would like to know from you is do this exercise and answer a few questions for me. Okay. So question is, for Scoop, there is a UI. I'll talk about it at the end of the class. But right now, I'm not going to talk about UI because you will first do it this way, and then I'll tell you what UI is available. Okay. So please answer following questions after you do the exercise. Okay, we successfully got data from MySQL to Hadoop, and from MySQL data is stored in Hadoop at which folder. You need to tell me the path where the data is getting stored in HDFS. Second thing you need to answer is, okay, we got data from MySQL. We got data from MySQL and we found that there were X number of rows in MySQL table. What is? So get started. Just one thing before you start, please run this command. The command is not in PDF. It's sudo service mysqld start and go on and complete exercise. All right. All right. So all you're doing is from MySQL, you are using scoop and getting data by HDFS. Then you're writing Hive queries, and you will be able to run queries on top. Now the only thing I want to know after the exercise is, you guys tell me, you got data successfully. Which folder does it get stored in HDFS? First thing. Okay. When you got the data from MySQL, how much number of rows are there in that particular data? And before you start, please run this command. This is very critical. You have 30 minutes to complete the exercise. So get started.
Can I ask you a quick question?
Yeah.
I'm trying to run this command scoop list databases.
Huh?
And after that there's a space and there's a backward slash. Is that correct?
Backward slash is basically continuation of the command in Linux. Okay.
Okay.
Just to tell you, backward slash is your way of saying my command is not complete, but I wish to go to next line. Okay.
Okay.
So
okay. That's grand, because for some reason I was.
if you are typing the entire thing in one line, avoid.
Okay. Perfect. Thanks.
I typed the exact command and I got an error saying no manager for connect string JDB.
Are you getting communication link failure?
Oh, sorry, I typo error. I'll try again.
Okay. Yeah,
Yes.
see, this PDF has been tested by 300 odd students, so exercise 5 at least for sure there is no mistake at all. So you just have to check your command once. You might have not started MySQL, just be sure of that, and everything else should be good. Absolutely.
This is actually the base SQL tool, scoop tool. I have the issue like it's saying setting user your password on the command line is insecure. Consider using -p instead.
Okay. So I guess you missed. So there are two ways. Either you do that, or I think you missed password. You would have missed one hyphen here. Is that the case? There are two hyphens before password. Got it, Money? All right. So can you share your screen, Money? Okay. Yeah, just share your screen. Okay. Oh yeah, I mean that's fine if you're getting your output, but yes, setting the password, you can do this, that instead of giving from the command line, you can basically what you call, give it from -p password, and it would ask you, prompt you the password so that it does not appear in your command. That's it, nothing else. Everything else is good. Yeah, it's perfect. Yeah, that's the same problem, Tang. See, you've not started MySQL. If you see the notepad, I've already conveyed that before you do anything, you need to start MySQL. Your MySQL service is not up, and what you need to do is you need to say sudo service mysqld start. Just run this command and rerun your command, everything should be good. Correct? Your MySQL service is not up. It's communication link failure. Can you come down, type this command sudo mysqld, sudo service mysqld start, and just rerun the command again. Yeah, sudo service mysqld start. No, okay. Come down, scroll down, scroll down. You have not started your MySQL. All you need to do is sudo service mysqld start and run all the commands in the PDF. Got it? Exactly. Good. Just run this and run all the commands as you've been running in the PDF. Everything will start working now. All right. Now just press up arrow key 2 times and you can run the previous command. Everything will work. Yeah. And run this now. Yeah. Enter. All right. Done. Right. Dank. Yeah. All you have to do is start your service that we've written in the notepad. Good. So just continue now. Let's see. How do I exit? To exit Hive prompt, you have to use exit. Getting error on the last command. Okay, tell me what error you're getting. I'll tell you.
It is like syntax error. It's saying for
Yeah, so then just check the syntax. Yeah, it's a semantic exception, then it's syntax. That's it. Is Hive case sensitive? Functions are case sensitive. Okay, table names are not. So it's there is no straight answer to it. So a few things are case sensitive, few are not. And again, it's trial and error. Stuff like functions, they are case sensitive. So count has to be case sensitive. Table names need not be. Statements need not be. So select in small or big is all same. So it's like that. Yeah.
I'm getting an error, no matching path HDFS this one, so
Yeah, but not a problem.
messed up the mistake step or
Share your screen. I will just. Okay. So select country count of 1 from Hadoop. Turn off the webcam. Okay. Okay. Select country count of 1 from user log group by country. So if you see select country, hey man, you need to go to Hive prompt. You first go to Hive prompt. You can't type it from here. You'll have to get there to Hive prompt. Okay, everything is from Hive prompt. Yeah, yeah. Okay. But I guess, yeah, if you dumped your data in a database, then you'll be doing it from a shell command only. So, I mean, from the Hive prompt only. So just run Hive, 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 and yeah, enter, and run this command. Run the last command. Wait a minute. Good. Now run the last command. Run the last command and you should be good. How does Scoop understand that, hey, I have to talk to HDFS? Point is, Hadoop is installed on your machine and Scoop searches for Hadoop config files. Searches for Hadoop config files. There it finds, oh, Hadoop is on local host, and then runs on local host. So if money worked on Oracle, you know tnsnames.org, right? You have Oracle client and that guy talks to the database. Similarly, you have Scoop client. That guy figures out where is Hadoop's config file and it looks that, oh, it's running on localhost, so it connects to localhost. If your Hadoop config was pointing to a cluster in New York, then Scoop will also connect to New York automatically. Got it?
So is there any configuration that need to be changed in Scoop when Hadoop is on a different machine or something like that?
No. So if there is a Hadoop on a different machine, your Hadoop configuration will change and Scoop will pick that up. See, right now your laptop, okay, your virtual machine, Hadoop is running on the same virtual machine, right? Okay. Let's say Hadoop was running in New York cluster. So you are sitting in Bay Area, Hadoop is running on New York. So your Hadoop client on your laptop will now say, I have Hadoop, but I'm not running Hadoop. I'm pointing it to New York cluster. And when Scoop is running on your machine, it will say, it'll ask your Hadoop. So can I import data to you? You are saying that I'm not running Hadoop. New York cluster is running it. So whenever you execute Scoop, it should be executed on the New York cluster. Got it? Now you're right. Hadoop client and Scoop client both are in launch. All right. So if everybody's done, can we start the next exercise?
Is there any chance you can actually tell us where exactly it's stored, the information on Hadoop folder, or what Hadoop folder it's used? I'm a little bit lost on that.
Just run Hadoop FSLS and you may find your answer. Can you just run Hadoop FSLS on your machine?
Yeah.
It is moved to Hadoop file system, right? So how do you access your file system or your workspace? Hadoop FSLS. Do you see something new there?
Yes. Yeah. Okay.
Got it?
Yeah. Perfect. Thanks.
And the other answer was there were 50,000 rows that got transported. And I think everybody got 50,000 right. Okay. All right. So let's get started with next exercise. Next exercise again is a 5-minute affair. I'll explain you. I'll show you that exercise. And after that, you guys can do it and call it a day. So as in when you complete, you can just call it a day. So hope exercise 5 was clear to everyone. Now let's talk about exercise 4. So look at this. In real world, when you code a map reduce, this is what the flow looks like. So first always is write your Java code. You will have to write your Java code, right? Then bundle the same as a jar file, submit it to Hadoop cluster, just like the way we ran the sample program. So all you're trying to do is you will write your Java code, bundle the same as a jar file, and submit to the Hadoop cluster. Fantastic. That's simple. Now I have already done one part for you. I have already written code for you. So all you need to do is you'll bundle it as a jar file, run the job, and see the output. Okay, very simple, really straightforward. Okay, is everybody clear with what I'm talking about, or somebody is not clear? All right. So now we will ask one of you guys. I'll ask one of you to share the screen, and let's do this. Okay, but before that, let me give you high-level steps. First, we will create an input folder in HDFS. This will be our input folder. We will dump some data in HDFS. So this is our input data. We bundle our code as a jar in Eclipse, and we finally run the code to get the output. Very straightforward affair. So who wants to share the screen? All right, guys. Next 2 minutes, just on screen carefully. All the instructions are in the PDF. Follow them correctly, and you should be good. Okay. Now let's start with the first thing. Let's create an input, what you call directory. So you are saying that Hadoop FS mkdir user training word count input. Word count input. So guys, just pay attention for 2 minutes here. Don't do it. Then you dump some input data. So you are saying Hadoop FS put word count.txt to user training word count input. Awesome. So you have your input data also in now. Now, what you need to do is you will see that I have written that code in home training exercises. So can you do ls home training exercises word count, ls ltr hyphen ltr, home training exercises, no, home training exercises. No, home has to be starting with the slash.
Sorry, yeah.
Home training exercises and word count slash word count.
It should be LTR, right? Yes, type LRT.
No, word count is not an empty file. It has data. Okay. So right now, what you see is that there are 3 Java files I have written for you: mapper, reducer, and the main class, which is the word count class, which is your main, where the main function is there. So what you see is that 3 files are coded for you. All you need to do is bundle it as jar file and submit it to the cluster. Now thing is, to bundle jar file we will use Eclipse, but Eclipse by default picks up the code from workspace folder. So we will copy these files to workspace and then open Eclipse. So now you start running the commands in the step 2.
Okay.
So you can just clear your screen and run command from step number 2.
Yep.
So you just say cp. Yeah, cp. -r. So now we are copying all the commands that I've had. So you are taking the code and dumping it into home training workspace word count. Exactly. Not required, not required. That's fine, yeah. Enter. Okay, cool. Now the next thing is your code is at the right place. Now open Eclipse.
Open Eclipse from
Applications,
okay.
programming,
Applications.
programming, and Eclipse. So guys, you are supposed to say open Eclipse new Java project. Okay, so okay. Click OK. So open Eclipse, it has to be new Java project, give the name as word count, and everything else will follow.
Okay, so
there's a file, new Java project. Okay. In Java projects, type word count. So the name of the project is word count, all small. Awesome. So when you do word count all small, everything gets grayed out because everything is defaulted. Say finish, just say finish. Once you say finish, you look at word count and you will see, can you expand word count default package? What do you see?
okay. So you
see all the 3 files?
all the programs here. Yeah.
Yes. But then you get errors. Why there are errors? Can somebody tell me?
Because there is no build path set up for the files, maybe.
Exactly. There are no Hadoop libraries set up for this project. That's a problem, right? So now what you need to do is you need to import the libraries. So you click on right click on word count and say properties. Say Java build path. Say libraries and click on add external libraries. Add external jars. Now on the left side you see file system. Yeah. And now navigate to a path called user lib Hadoop. User lib Hadoop. User lib Hadoop. And select all the jar files. Fantastic. Then again say add external jars once more. And this time you need to go to user lib. So file system, user lib, Hadoop 0.20 map reduce. And select all the jar files. Say OK. Now what you should see is all the errors are gone. So you're all done. Now right click on word count and say export it as a jar file. Say Java, say jar. Okay. Click on jar. Yeah. Click on jar and say next.
Yep.
Say browse. So you are already in your home training. You need to just say word count. WO all small word count and say OK. So this will create a jar in home training word count. Say finish. Finish. You're done. Now close Eclipse. Now, can you do ls-ltr? Do you see something new?
Yeah. That
Word
word
count.
count chart.
Now run this program. So just say Hadoop jar word count.jar. Now space main class name, which is word count, W capital C capital, space word count input and word count output, all small, because your input path is word count input folder, which is small. Word count input, input. That's the folder you created, right? And
Correct,
word
yeah.
count output is your output folder. All right, just say word count output. Press enter and you are done. Okay, press enter. The program runs. So successfully done. Then Amrish, can you tell me how will you see the output? You've already done that. How to see the output?
Yeah, Hadoop. No, sorry.
Yeah, you're right. Go ahead.
Hadoop FOS
Hyphen
minus
ls,
ls.
hyphen ls. Enter. Do you see the output that you need? Which folder should have the output? Exactly.
Word count.
How
Word
do
count
you,
output.
so you just say Hadoop fs hyphen ls word count output, and you will see a part file there. So you see your, now what you do is you say Hadoop fs cat word count output part 00000, and what you get is the word count of all the words in word count.txt.
So guys, that's all for today. I hope this video was informative. Stay tuned to Intellipaat channel for more such informative videos, and we'll meet in the next session. Okay, till then, bye bye. Thank you.